See, today's class is all about finding the fair price of a call option or a fair call option price. Okay. To find out the fair price of a call option or call option price, whatever you want, you can say there are two models we have. One is one period binomial pricing model, and another one is risk neutrality model. So here we have one period binomial model for a call option. Okay. So I will do this model. I will, explain this model. This model will help you to find out the value of the call option. And also the next model, we will also do the same thing for value of the put option. And then we will take up the risk neutrality model. And again, we'll try to find out the value of the call option. And both are very simple ones. Okay. Let's begin. So here is the data we have. So one period binomial, one period option pricing model, binomial option pricing model. So current stock price is given to you $50. Strike price $55. Time to maturity 1 year, let's say. See, the stocks can go, the stock, what we are holding can go up and down. Okay. We'll take the data from the text. Okay. So time to maturity 1 year. See, up state stock price. That means up stock, upward movement, I will say. If the stock moves up, it reaches to 60. If the stock goes down, it reaches to 42. Fine. And the RFR is given in the question 3%. Fine. See, the call option, let's say you have taken a call option, let's say. Fine. So we can calculate the payoffs of the call option, okay, at maturity. Fine. But today we want to find out what? The payoffs we definitely know. As you know, there is a strike price given to you, and you definitely have fixed the price to buy a stock at 55, irrespective of whatever the price is on that day. If the price goes up, if the stock price goes up, you exercise. If the stock price goes down, you let it lapse, worthless. Fine. And here we will also construct a portfolio. We will call it as a hedged portfolio. Okay. Because we will combine stocks along with call option. We will short a call option. Okay. And we will go long in the stocks. Fine. So we'll make a portfolio also. So call option, this like we are going with the next step right now. This is the step one model setup. Step two, we will find out the payoffs of the option. stock up. So call option when the stock goes up, maximum of stock is 60 minus strike 55 comma 0, it will be 5. When the stock goes down to 42, call option value when it goes down, maximum of 42 stock minus strike comma 0. And here it will be 0. Fine. So these are the call option payoffs in step 2. Third step, see, we are going to construct a portfolio. We are going to take option along with stock. See, movement in the option, okay, we'll see the movements. When the stock has gone up, you see the payoff. When the stock has gone down, you have seen the payoff. And the stock also, when it goes up, it has become 60, goes down, it becomes 42. So movements in stock is also seen, and movements in option is also seen. We have to make such portfolio, hedging portfolio, whereby these movements of stock and option should nullify each other or strike off each other or zero out. That means the movements in the option and the movements in the stock should become zero. Okay, for that reason, we make a hedge portfolio. We don't make a replicating portfolio. Hedge portfolio, what it will do, it will make sure that the movements in stock and the option, values right now we are seeing, should nullify itself or should zero down itself or should offset itself. Okay, so I will also prove that point to you. First, I will give you the equation of that portfolio. So third step, construct a hedged portfolio. So portfolio A and portfolio B will make, or up portfolio. When the stock goes up, there will be a portfolio. When the stock goes down, there will be a portfolio. Both the portfolio should be equal. Actually, when we naturally see, they will never be equal. Not they will not be equal, but we can make them equal with a very proper combination of the number of stocks for one call option. I will explain you all those points, need not worry. See, your question, what they give in the exam is not about solving the numericals. These days, they are not testing students with numericals. They are testing with strong conceptual knowledge. Why are you making a hedge portfolio? That is important to understand. Hedge represents the hedge ratio, very important, which makes the portfolio value equal in LHS and RHS. Without this, these two portfolio will not be equal. I will tell you how and why. H represents the number of shares, how much we need to take for one call option. That is also equivalent to hedge ratio. For one call option shorting, how many shares we should be holding. So I'm again saying you, we build a portfolio so that we can find out the fair price of the option without arbitrage. And for that, we construct a hedge risk-free portfolio, which includes long delta or H shares of stock, short one call option. So you have sold the option to buy to someone else, and the other person, when the stock value goes up, will exercise the option. Okay, with if you are long on call option, you have the option to, you have the right to buy, but here you have the obligation to sell. Okay, when the other person will exercise the option, he has the obligation to buy. He has the right to buy, but you have the obligation to sell. Just a minute. Just wait a second. Yeah. So it's like, we are going to find out the hedge ratio, which we are representing with H. So which will tell you how many options we should be shorting for one stock. That's what we are going to learn here now. Coming to the calculation part, we will do the calculation right now. Okay, I was here. So this is the portfolio formula. Okay, as they have given in the text also. Yeah. So this is the portfolio what they are making. Fine. So I was saying you, not always they will be equal, right? So if I take one share and short a call option, and if I make a portfolio, it's not like always they will be having the equal values. To make them equal, what are we doing? To make them equal, we are taking this hedge ratio or calculating the hedge ratio. So see here, I will explain you in a different page. So the question, basic question, why to build a portfolio? See, we want to calculate what fair price of the option without arbitrage. So what we need to do that, we construct a delta hedging portfolio. We are using delta hedging method. Which is risk-free portfolio. That includes what? Long H or delta shares of stock and short one call option. See, stock will move up and down on the date of maturity, but option only upward movement we consider, downward we won't consider, right? So see, what is the important point to be noted here? Option and stock do not naturally cancel out in value when stock moves up or down. They do not naturally do it. So definitely, when the stock will go up in value and option, you are combining the stock along with option. Okay, you are having long stock, you are having short call option. So when the other party will exercise the option, what will happen if the stock goes up? You have to like that is your loss, correct? So the net we will see we will see the net portfolio values and they will not be equal. To make them equal, we will calculate the hedge ratio. So check it out. The option and stock do not naturally cancel out in value. And stock moves up or down. Because we are saying the portfolio, what we are making here, the portfolio of the stock, as I gave you the equation right now, the portfolio of the stock, this one, with some, hedge ratio. Okay, we are taking this purposefully to make the portfolio equal in both the sides. Otherwise, naturally, this portfolio of normal stock without hedge ratio and the option, okay, will not be equal when they go up and when they go down. Will not be equal. See how? Okay. There's an example here. You have taken one share of stock and you have taken short call. What you will get, you see, and you yourself will understand. Stock has gone up to 60. The stock value has become 60. No space. See, when the stock has gone up, you have short the call. When you short the call, the other person will exercise the option. He will gain, you will lose, right? So you lose 5. Your net portfolio value is 55. When the stock has gone down, 42, what happens? The stock value is 42 and the payoff is 0. Fine. The other person will not exercise the option. So premium you will be your income, but here we have not explained anything about the premiums. We are finding the option price. The entire model is to find out the option price. So you have taken a portfolio of a stock and a option, and you saw the payoffs, and you see the net portfolio values. They are not equal here. That means the risk is still existing. Hence, we need to make a hedge portfolio to remove that risk of arbitrage. Gain or loss on the stock perfectly offsets. This kind of points in textbook will not be very clearly given. Tough to interpret on the call. So now see, we will prove that point right now and we'll calculate that edge ratio also, and I'll prove that you have the same payoffs. See, now we calculate the hedge ratio. See, hedge ratio H is nothing but call up minus call down divided by stock up minus stock down. That means change in the call option payoffs with respect to change in stock values. What is the change when call was up 5, right? Your payoff down 0. What is the stock up? 60 minus 42, 5 by 18, 0.278. This is the hedge ratio. What does it say? What does it say? It says that we will now construct a hedge portfolio. It says that for every one short call, you will long 0.278 shares of stock. For every one short call, you will not long one share or one stock. For every short one call, you will long 0.278 shares of stock. That means this much part of the stock. If this is 0.2, that means one third. If this is 0.278, if I change this into fraction, Just a second. 0.278. So we will convert that into fraction. Exactly, we will get, 278 by 1000 we do. It's coming 139 by 500. Okay, let's say I simplify it. Let's say it is 0.33. What does it mean? What do you interpret with 0.33, Hepzibah? With 0.33, you kind of interpret 1 by 3. 1 by 3 of 1 by 3 part of a stock. That means 1 by 3 part of a stock is what? One third of a stock. Okay. For every one short call, you will be long one third or 1 by 3 value, 1 by 3 part of a stock, 1 by 3 fraction of a stock, not the total stock. Okay. That's what the interpretation I've given here. That's coming 139 by 500. If I simplify again, it goes in decimal. So no need. So I have written for everyone. It's not for every one short call, you will be long on one stock. For every short one call, that means if you short one call, okay, you have to be 0.278 shares long of a stock. That gives the exact combination to make this particular portfolios equal. Okay, now see how I will prove you that the payoffs will be same, which will give you a very strong understanding about this. And we will find out the call option value also. See, if stock goes up to 60, okay, V up, stock goes up to 60. So what will happen? Stock value is equal to 0.278 we have to take into 60, right? Loss on short call. See, it was not one stock into 60. It is 0.278 stock into 60. Not the total one stock, 0.278 part of that stock. Or 139 by 500 part of that stock. Whatever you want, you can say. Loss on short call, 5. I subtract, I get 11.68, right? Net payoff. So now my portfolio is giving, my portfolio when the stock has gone up is giving this. My portfolio when the stock goes down is giving what? Again, not one stock, 0.278 stocks, part of a stock. And here, when the price goes on call, expires worthless. 0, 11.68 net payoff. So this will prove my point here that if this is the combination I do not have one stock and one short call. No. If this is the case, I will never have both the portfolio values equal. So to make it a perfect hedge portfolio, I will take 0.278 in stocks and one short call. And in that case, whatever the payoff I get will always be equal whenever the stock goes up or down, or whenever the option goes up and down because of the stock going up and down. So whatever the movements in the stock has happened and whatever the movements in the call option has happened, they both offset with this particular combination or this element taken in the portfolio. Okay. So now I have proved my point. Now I will finish it off. Now let's do the calculation. So this, if the portfolio goes up, That should be when the portfolio goes down. H into stock up minus call option. Why minus? Because we have short a call. So we need to give the, whenever the buyer is in gains, we are in losses. So stock up value is 60. I was going perfect, right? Yeah. Construction of the portfolio. So if it comes here, 18H. This is the hedge ratio. We'll take the hedge ratio and try to find out the portfolio value. So hedges to 0 point. So we have proved that point. Same payoff. And okay, stock up and stock down. We have already found out the values, right? Hedge ratio we have calculated. Okay, we'll do that now. Stock goes up to 60. It is H 0.278 into 60 minus 5. If stock goes to 42, 0.278 into 42. Both the cases we got the same payoff because of the hedge ratio. It was not possible with one stock and one call option short. It's only possible when one call option is short and 0.278 shares are long. Now this has become a risk-free portfolio. The payoff is, risk-free. We will discount this to the present value. So value of the portfolio as on today, these are the future payoffs. 11.68 divided by value of the portfolio today is equal to hedged into stock today. Okay. Minus the call option as on today. We are dealing with the European call option. So we have to find out the value of the option as on today. So we will first find out the value of the portfolio today. 1.03. So it will become 11.34. So we will put this in the equation and find out the call option value. So value of the portfolio today is equal to H into stock price today minus call option today. 11.34 is equal to 0.278 into stock price today is 50 already taken in the question. Call option 11.34. This one we multiply, it's getting how much? 7, 8, 13.9. So I'll bring this call here and 13.9 minus 11.34. The value of the call option as on today is what? 2.56. This is your answer. In the similar way, we can do for put option also. Okay, you would just have a look through this. We'll go for put option. Okay, let's do the same thing for put option also. One period binomial model for put option. Just a minute, huh? Just a minute. Okay, so when we go for 1 period binomial model for put option, we will take the stock price as 50. We will take the strike price as how much they give here. Option. Same assumptions. Okay. What's that? So they get 50, 60 is increase and decreases 42. Okay. And the strike price is where is the strike? They have not given the strike price. Currently it is 50. Increase to this and decrease to this. Exercise price of 48. Okay. So this is the exercise price. Fine. And if the stock has gone to up, stock up is equal to 60. Stock down it is equal to 42. So see in the previous example also there was some up and down. Up how much up it has gone and how much down it has gone. We can find out that also. 60 by 50, 1.20, 20% up. And 42 by 50, 0.84, 16% down. After we will do the risk neutral probability, this will be an important factor.